Good day. Today we shall be having now the exact differential equation wherein we shall be using now the partial derivative methods. So we shall have now our review of our past lesson, which is using the line integral method in finding the general equation when the given equation is exact. Using the line integral, so this happen to be your idea of finding out the general solution. So first, take note that this is the reminder in finding the general equation. First, we treat y as constant, and the second, we have to replace x by the value of a. So let's have a problem. Let's say find the general solution of the differential equation 2x plus 3y minus 5 dx plus 3x minus y minus 2 dy equals to 0. Again, we shall be testing the given d, whether the given d is an exact equation. First, we identify m, which is 2x plus 3y minus 5, and n to be equals to 3x minus y minus 2. And then we get the differential of m with respect to y, wherein y is constant. So therefore, you have now 3y, or x is constant, so therefore the derivative of 3y is 3. While in the second one, we have to get the differential with respect to x, wherein y is constant, therefore the derivative of 3x is 3. So therefore, this given differential equation is an exact differential equation. So we shall be having now the integral method. So we have to integrate the 2x to x plus 3y from 0 to x, where a equals to 0, while n should be b or 0 to y. Means that we have to get the integral in terms of x, wherein y is constant in the first. So meaning that 3x is subjected to be equals to 0. Since our reminder in finding the general solution is you have to integrate the first, wherein we have to treat y as constant, meaning that we have to get the integral in terms of x, where y is to be constant. While in the second one, we have to get the derivative of y, wherein we shall have to replace x by the value of a. Since a is 0, meaning 3x is 0. Okay, so therefore 3x is 0. So you have now to integrate. So therefore 3x is 0, so negative y minus 2. So integration of x, so you have, it becomes 2. Integral of x is x squared over 2 plus 3. Since y is constant, meaning, so therefore, meaning you have to get the integral of x. So you have 3xy. The integral of dx is x, so it equals to 3xy. Minus integral of 5 is 5x from 0 to x. While in second one, we have to integrate of negative y. So negative y squared over 2 minus 2y from 0 to y equals to c. So therefore, it becomes x squared plus 3xy minus 5x minus y squared over 2 minus 2y equals to c. So we have to have now the fraction to be eradicate that by multiplying it by 2. So our answer will be 2x squared plus 6x minus 10x minus y squared minus 4y equals to c. Or we arrange that into its specific exponent. So it becomes 2x squared minus y squared plus 6xy minus 10x minus 4y equals to c. So that will be the desired general solution for the given DE, which is an exact equation. Now we shall be going on with our fourth method, which is partial derivative method. In using the partial derivative method, we shall be again considering the standard equation of the DE. We shall be serving it as equation 1. So if uh, the equation M and equation N is exact equation, so we consider now to be we shall be getting a solution to be getting the integral or function of that will be equals to C. So getting the functions of M as it will act as equation 2, and letting derivative of function in terms of y, that will be our equation 3. So to get now the general solution, so we have to determine from equation 2 by integrating both sides with respect to x. Please take note, we have to integrate both sides with respect to x, treating y as constant, where the usual arbitrary constant in indefinite integration is a function of t function of y, which is yet unknown. To determine the t function of y, we have to obtain the differential of f with respect to y, and we equate that to equation 3, which is our n. So our n, and then we have to integrate. This time, no constant is needed in obtaining t sub y or t function of y, since once being introduced on the right side is the solution, which is f is equals to c. So we have now to define the general solution of these two given examples. So in problem, find the general solution of the differential equation 2x plus 3y minus 5 dx dx minus y minus 2 dx dy. So we have to check that. We already have that in our previous review example. So we ought have to have the same differential, which is equals to 3. So therefore we found out that it is an exact differential equation. So therefore we shall be serving the function of m in terms of x as our m, our equation 2, and then the function of a function that will be in terms with respect to y, which is considered to be our n. So our m is 2x plus 3y minus 5, and our n is 3x minus y minus 2, depending on our given problem. So it should be serving as our equation A. So we have to integrate with respect to x to solve for f. So therefore we have now f is equals to, we are serving for m, so integral of x is x squared over 2 plus integral of 3y is 3xy with respect to x, and the integral of 5 is 5x, and we shall be adding now the t function of y. Solving or simplifying, so our f is equals to x squared plus 3xy minus 5x plus t function of y, and it will be serving as our equation C. So differentiating with respect to y, the differential of f with respect to y, so we shall have now 3x plus t prime y. So therefore, in our previous slide, we have to differentiate, and the remaining function or equation will becomes 3x plus t prime y. The t function of y, when we get that to the derivative that becomes t derivative of y, and it serves as our equation B. Equate A and B. So you have 3x plus t prime y equals 2. You shall have to equate that to 3x minus y minus 2. That is our equation B. So therefore, you have t prime y or t prime y solving for this last equation that becomes t prime y equals to negative y minus 2. So we have to integrate that to solve for ty. So ty is equals to negative y squared over 2 minus 2y. And we shall be serving that to our given function. So t prime y equals to negative y squared minus 2y in C. So we have to have now our function that will be x squared plus 3xy minus 5x minus y squared over 2 minus 2y equals to C. So therefore, our answer is we have to multiply it by 2. So our answer is 2x squared plus 6xy minus 10x minus y squared minus 4y is equals to C. I think we have in the second example, we have to find the general differential equation of tx squared. Again, we have to check whether the given d is an exact. So this m will be in terms of y, wherein y is constant. So therefore, you have 3x squared. That will be the derivative. While in x cubed, 2y is constant. So therefore, you have 3x squared. So they are exact differential equation. So serving to be our differential of f with respect to x is 3x squared, our m. And the differential of function of f with respect to y is x cubed plus 2y, that will be our n, and serving to be our equation A. So integrate with respect to x to solve for f. So we have to integrate this with respect to x. So it becomes 3x cubed over 3, y is constant, then 6x squared over 2 plus, we shall be adding now the t function of y. F is equals to x cubed y, simplifying. So it will become our equation C. Differentiate the equation C with respect to y. So it becomes x cubed plus t prime y, and it will be served as equation B. So therefore you have to equate A and B. So you have x cubed plus t prime y, that will our equation B is equals to x cubed plus 2y, which is our equation A. So t prime y, it becomes 2y. And then we integrate that for solve for ty, so it becomes 2y squared, which equals to y squared. And then we shall be adding that to f of c. So t prime y equals to y in c. So f is equals to x cubed y plus 3x squared plus ty equals to c. So we have to substitute y squared here. So you have x cubed y plus 3x squared plus y squared is equals to c. And that will be our desired general solution for the given DE, which is exact. So next time, we shall be having now our next topic, which is the lesson 8, non-exact differential equation. Good day and good luck.